graders, this is Eureka Math. We are in Module 5 and this is Lesson 13. Our objective today is to multiply mixed number factors and relate to the distributive property and the area model. So we've been doing this. So it's just more of the same, so it's just good practice. Some of you are still needing some practice on this, so please let's go to the problem set. Write your name on the paper. And number 1, we're going to dive right in. Find the area of the following rectangles. Draw an area model if it helps you. I am going to draw an area model for every single one of these so that you guys can see what we're doing here. And I'm also going to turn these into mixed fractions so that I can see a little bit better what I'm doing here. Okay. So 1 1/4, so I turned this into 1 1/4, and I turned 12 fifths into 2 2/5, so that I can call that 2, and this 2 fifths, and then this way can be 1 and 1/4. So now I can just multiply. 1 times 2 is 2. 1/4 times 2 is 1/2. 1 times 2 fifths is 2 fifths. And 1/4 times 2 fifths is 2 20ths, okay? Or we can make that 1/10 if we want to simplify it right away, okay? Now in order to find out the area, we're just going to add those together. 2 plus 1/2 plus 2 fifths plus, and I already simplified that one to 1/10, okay? Now I just have to make sure that I have common denominators for all of my numbers so that I can add them easily. And I'm going to use 10 as my common denominator. So this fraction is going to turn into 5/10. Okay. This one will be 4/10. And that one is 1/10. And if you don't remember how I did that, I just multiplied 2 times 5, right, to get 10, and 1 times 5 to get 5. All right. So there we go. There are my new fractions. Now I can add them pretty easily. 2 plus 5/10 plus 4 is 9/10 plus 1 is 10/10. So 2 plus 10/10 is in fact 3. Now I have to use my label. So I've got kilometers, and because it's an area problem, squared. Okay? All right. Area equals 3 kilometers squared. Next one. 16 meters times 4.5 meters. Okay, I'm going to draw my rectangle up here. And I've got 16 going this way and a half, and then 4 going this way and a fifth. So 16 times 4, let's see, 16, when I'm thinking I shut my eyes sometimes. 16 times 4 is 24. 4 times 1 is 4, plus 2 is 6, so that's 64 right there. And 1/5 times 16 is 16 fifths. 4 times a half is 4 halves. And 1/5 times 1/2 is 1/10. Now, 64 plus, and 4 halves is 2, so I'm just going to add that right there, okay? And 16 fifths is 3 and 1/5. And then here I've got 1/10. Okay, so I can add the whole numbers. 64 plus 2 is 66, plus 3 is 69. Now I need to change that 1/5 to common denominator, so I'm going to multiply by 2, and I'm going to get 10, and that's going to give me 2 on the top. So 2/10 plus 1/10 equals 3/10. Okay, and I have to use my label, meters squared. Okay, I'm going to erase this yellow just so get it out of the way there. There's my answer. Okay, next one. 4 1/3 yards times 5 2/3 yards. Okay, 5 2/3, and here I have 4 1/3. So 4 times 5 is 20. 1/3 times 5 is 5/3. 4 times 2/3 is 8/3. And then 1/3 times 2/3 is 2/9. So I've got 20 plus 5/3 plus 8/3 plus 2/9. Okay, so now I've got 5 plus 8 is 8, 9, 10, 11, 12, 13/3 plus 20 plus 2/3. And I'm going to go ahead and, 2/9, I'm sorry. I'm going to go ahead and change that. Okay, instead of 13/3, 3 goes into 13 4 times with 1 left over. So 4 1/3, right? 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 goes into 13 4 times with 1 left over. Okay, good. So 24 plus 1/3 plus 2/9. And I'm going to change this, right, to 3/9 so that we all have the same common denominator. And that's going to equal 24 5/9. And my unit is yards squared. Okay. Letter D. I'm going to switch to colors here. 7/8 times 4 1/3. Okay, 4 1/3 times 7/8. Okay, so 7/8 times 4 will be 28/8. And 7/8 times 1/3 would be 7/24. Now I just need to add those together. 28/8 plus 7/24. Okay. And 8 goes into 28 3 times with, well, 4/8, right, left over. But I could also call that 1/2. Okay. And on this side, can I simplify that? I don't think I can. Ooh, I'm going to sneeze. Excuse me. 7/24. So I'm going to change this to 24ths by making it 3 12 24ths plus 7 24ths equals 3 19 24ths. And my units are miles squared. Okay. There's this answer's here, and this answer got a little smushed there. If you can keep that up on that space, that'd probably be better for your paper. Number 2, Julie's cutting rectangles out of fabric to make a quilt. I like to make quilts. I made a quilt for my cousin for his wedding, and I used all these pretty colors. It was fun. Now, when you make a quilt, which is a big blanket, right, made up of little pieces, you have to be really careful because sometimes the pieces get a little angly. Actually, well, I won't get too distracted. I do have some quilt patches I could show you. Okay, Julie is cutting rectangles out of fabric to make a quilt. If the rectangles are 2 1/3 inches by 3 2/3 inches, okay, so we've got 2 3/5 by 3 2/3. Okay, so this is the length and that's the width. What is the area of 4 such rectangles? 4. Okay, so we're going to find the area of this rectangle, and then we're going to multiply that by 4. Okay, they're kind of throwing a little curveball in at you. 2 times 3 is 6. 3/5 times 3 is 9/5. 2 times 2/3 is 4/3. And 3/5 times 2/3 is 6/15, right? Okay, so 6 plus 9/5 plus 4/3 plus 6/15. Okay, and I want to make the common denominator 15 here. I think that would be the lowest common denominator for all of those. So here I'm going to multiply by 3. That's going to give me 27/15 plus 6 wholes. Here I'm going to multiply by 5, and that will give me 20/15. And this is already in 15ths, so I can just add 6/15. Okay. Now 27 plus 20 is 47, plus 6 is 48, 49, 50, 51, 52, 53. 53/15. 6 and 53/15, but let's simplify that. 15 will go into 53 3 times. Okay, so that would be 45, right? 15 times 3 is 45. So 53 minus 45 is 8. Okay, so I've got 9 and 8/15, and that's just one of these squares, but we want to create 4, okay? So picture one rectangle, another rectangle, another rectangle, another rectangle, and that's how she's going to build her quilt, okay? So we're going to multiply this by 4. And here we're going to use a little bit of distributive property, although secretly we have been this whole time. 9 times 4, okay, plus 8/15 times 4. So this is going to give us 36 plus 32/15, okay, which equals 2. I'm going to take that 2 and 2/15, which would make 4 together 38 and 2/15. And what are we working with? We are working in inches, right here, inches. Okay, so 38 and 2/15 inches squared. So that's about like that. If she did that 8 more times, she'd have a full bedspread. Okay. Number 3, Mr. Howard's pool is connected to his pool house by a sidewalk, as shown. Okay, well, let's look. He wants to buy sod. Oh, this is a complicated one, I can tell already. Buy sod for the lawn, shown in gray. So if you don't know what sod is, have you ever walked past a park or a golf course where the grass was so green you didn't think it could be real? Okay. What they do is they buy sod and then they roll it out, so it's just the top layer of soil, okay? So he wants to buy that top layer where all the grass is nice and thick, and he wants to cover his lawn in sod, okay? And that's the gray section. So all of this, I'll use green because we're talking about grass, right? So all of this gray section, he wants to put sod or grass, okay? Now, we have to find lots of things here, okay? So this, we have to find, first of all, we have to find the area of the pool house. we have to find the area of the pool, the area of the sidewalk. So those three things we have to find the area for. We also have to find the area of the whole yard and subtract those three things. Okay? So what would you like to start with? Let's just write it all out, the entire expression, so that we can see what we're doing, and then we'll start working from there. Okay, so first of all, the whole place, this whole big yard is a square, so it is 24 1/2 times 24 1/2, and that would give us the area of this whole thing. But now we need to subtract the area of the pool house, the area of the pool, and the area of the sidewalk, okay? So the first one is the pool house. What times itself is going to give us 16? It's a square root problem. We haven't done square roots. But think about it this way. It's a square, okay? So the length of this pool house and the width of this pool house are the same, because we know the area is 16 yards squared. So 2 times 2 would be 4. 3 times 3 would be 9. And 4 times 4 would be 16. If it were any bigger, 5 times 5, it would be 25. So that we already know the answer. We know that the length and the width is 4. Okay? So in fact, because we already know this area, we don't even need to know that. We're just going to subtract 16, because that would be 4 times 4, from the area of the whole big space. Now we have to, there's a reason that I looked for that, okay? Now we have to figure out what's the area of the sidewalk. Well, it's 3 yards this way and 1 yard that way. So 3 times 1, which would be length times width, equals 3. Okay, so then we're going to subtract, well, I'm going to put big brackets here. We're going to subtract 3. Okay, and I don't even need the, well, sorry, we're going to add those inside here because it's part of this. So this plus this plus this is going to give us the whole number that we're going to subtract from there. I'm sorry, when I put the subtraction sign, that was wrong. Okay, and then finally we have to find the area of this pool. Okay, so it's 2.5 times 7.5. So the area of the pool equals 2 1/2 times 7 1/2. And I'm going to use my distributive property. 2 times 7 plus 2 times 1/2 plus 1/2 times 7 plus 1/2 times 1/2. Okay. So 2 times 7 is 14. 2 times 1/2 is 1. 1/2 times 7 is 3.5. And 1/2 times 1/2 is 1/4. Okay, now I can just add those together. 14 plus 1 is 15, plus 3 is 16, 17, 18. And then I've got a half here, but I'm going to turn it into 2/4, plus this 1/4, which is going to give me 18 3/4, and that is yards squared. Okay, so I know that 16 is the area of the pool house, 3 is the area of the sidewalk, and 18 3/4 is the area of the pool. 18 3/4. Okay. Now I just need to add those. All right. This is the next step. 16 plus 3 is 19. 19 plus 18 is, wait a minute, 16, 17 plus 1, 8 is 9. What am I doing? I'm adding, not multiplying. Okay, 8 plus 9 is 17, plus 1, 1, 2, 3, 37. Okay, so I have 37 and 3/4. 37 and 3/4 right here. And I'm going to, now I need to multiply this, okay? So 24, I'm sorry, my water pump is kicking in and it's really loud. ¿Se puede apagar eso, porfa? Thank you. 24 times 24 is that, and then 24 times a half would be 12. We already know that 24 times 12, so I'm just going to put 12. And a half times 24 is 12. And 1/2 times 1/2 is 1/4. Okay, so 24 times 24, what is that? 24 times 24 is 16. Okay, the 1 is 8 is 9. And then a drop a 0, and that's 8, and that's 4. So my answer is 576 plus 12 plus 12. So I'm just going to make that 24 right away. 24 plus 1/4. Okay. And that would make this number 10, 8, 9, 10. Plus 1 is 600. Oh, well, that makes sense. 600 and 1/4 yards squared. Okay, so that is the area of the whole big thing. Okay, but now I need to subtract this number. Okay, so 16 plus 3 was 19. 19 plus 18 is 37 and 3/4. So I'm going to actually move this down here. So I've got back to my original problem here. The area of the whole yard is 600 and 1/4 yards squared minus 37 and 3/4 yards squared. Okay, now it's just an addition-subtraction problem, except I have 3/4 on this side and only 1/4 on this side, so I'm going to just switch that. 599 and 5/4 minus, and I'm taking the units out, but I'm going to put them back in the end. 37 and 3/4, so 599 minus 37 is 62, 562. Okay, and then 5/4 minus 3/4 is 2/4, but I'm not even going to write 2/4. I'm just going to immediately write 1/2 yards squared. So he's going to have to go to the lawn care store and buy 562.5 yards square of sod. I'm going to erase this and write that in there too. Of sod. And what did I say sod was? Sod's grass. Okay? Grass that you can roll out. Ooh, that one took us a minute. Lots of work there, but do you see how we did that? We found the area of the pool, we found the area of the pool house, we found the area of the sidewalk. We added those three together. Then we found the area of the whole space and then subtracted those things because we're not going to put sod over the pool. That doesn't make sense. Okay, great. Homework, just more problems. And if you want to use improper fractions, you can. If you want to turn them into mixed fractions, you can do that as well. And your exit ticket are 2 problems right there. Okay, and it does say draw an area model if it helps you. I would like to see the area model so that I know that you know what you're doing. So I'm going to take this off, and I want you to draw that area model. Okay, great. I hope that you're understanding this. Have a great day.